All right, today we're going to challenge a really core belief in the crypto world, this whole idea of a single global world computer. We're going to dig into a pretty radical critique of that vision and then uncover a totally different way to think about building a decentralized future. So let's just dive right in.
Okay, so this quote right here, it really kicks things off. The key phrase is brute force. Now, this isn't saying blockchain is bad, not at all. It's reframing it. Think of it like this. Blockchain proved, yeah, you can have decentralized consensus. It smashed down the door and showed it was possible. But it did it with overwhelming force, in a way that might not be the smartest or the most scalable in the long run. So what does that actually mean? Let's unpack.
Okay, so first, let's talk about that big, beautiful promise, the idea that got everyone so excited, the world computer. I mean, you gotta admit, the initial pitch was incredible, right? Just picture it. One single computer for the entire planet. A machine that could run everything. Decentralized finance, social media that nobody could shut down. The dream was to get rid of all the middlemen, all powered by this one shared source of truth. It's such a powerful, almost utopian idea. But, and here's where our source throws a bit of a curveball. The argument is that as the real-world technical problems started piling up, the definition quietly changed. This grand world computer vision kind of morphed into something less ambitious, a settlement layer. But the branding, that powerful world computer idea, that stuck around. The source calls this definition laundering. So was it just a necessary pivot or something a little more slippery? So what was this massive technical hurdle they ran into? Well, the argument we're looking at today says it wasn't just some software bug you could patch. Nope, it's a fundamental limit, something baked into the physics of it all. And to get our heads around this limit, we have to talk about something called data availability, or DA for short. It's actually a pretty simple idea. In a system where you don't want to trust a central company, you can't just take their word for it that the data is correct. You need to be able to check it yourself. Data availability is just that guarantee, that the data has been published and you or anyone else can actually download it and verify it. It's the bedrock of the whole don't trust, verify mantra. Okay, so here's the problem. When you try to force every single transaction in the world, I'm talking buying coffee, trading complex assets, sending a quick message, into one single line, one global queue, well, you get chaos. It's like a one-lane highway for the entire planet. You get traffic jams, you get people trying to pay to cut in line, that's MEV, and you even get risks where one person's buggy transaction could mess things up for everyone. Our source calls these the four horsemen of this global ordering problem. And all of this leads to what the source calls the DA bottleneck theorem. Now, don't worry about the math on screen too much. All it's really saying is that the total speed of the entire system, including all the layer 2s you stack on top, is ultimately limited by the data capacity of that base layer. No matter how many fancy L2s you build, they all have to post their data back to that one-lane highway. You just can't escape it. It's like trying to drain an ocean with a straw. And this slide right here is the absolute heart of the argument. Look at the difference. On the left, with the blockchain model, throughput is basically constant. It's limited by that shared global budget. More users, more rollups, doesn't matter. The pie doesn't get any bigger. But look at the right. With this other model, deterministic state machines, or DSM, the throughput is additive. Every new device, every new user adds to the total capacity. The system scales with the number of people using it. That's not just an improvement. That's a completely different paradigm. And the author's point is that this isn't just a temporary software problem that some brilliant engineer is going to solve next year. This is physics. It's information theory. At the end of the day, the bytes have to be uploaded and the bytes have to be downloaded. You can't just wish that away with clever code. It's a hard physical constraint. So if that's the problem, if the whole world computer idea is fundamentally bottlenecked, what's the solution? Well, let's look at a radically different way of thinking about this. This alternative approach, called deterministic state machines, or DSM, starts from a completely opposite premise. It says the world isn't one computer. That's the wrong model. The world is billions of devices that just need a standard way to trust each other. Forget the single giant machine. Focus on the endpoints. So it totally reframes the problem. Instead of asking, how do we get 7 billion strangers to agree on everything all at once, it asks a much simpler, more common sense question. How do two people who already have a relationship transact with each other with trust? Think about it. That's most of what we do online, right? Paying a merchant, messaging a friend, sending money home. Okay, so how does this actually work in practice? The core idea is surprisingly simple when you stop thinking about a world computer and start thinking in terms of communication channels.
And the walkie-talkie analogy is perfect for this. Think of a blockchain as one big public party line. Everyone is on the same channel, you have to shout over each other, wait your turn, and everything you say is heard by everybody. Now, compare that to DSM. It's like giving every single pair of people their own private encrypted channel. You and your friend can talk, and nobody else is even on the line. You don't have to wait for anyone.
And this architecture leads to some really powerful properties. Because the state is just between you and your counterparty, it's totally private. The verification, the check to make sure everything is legit, happens right there on your device at the endpoint. The network in the middle, it doesn't need to be smart. It's just a bunch of dumb mailboxes passing messages. It has no authority. And crucially, the system guarantees that the message you sign is the exact same message that gets executed. No funny business. And check this out. This is where it gets really cool. This design works perfectly whether you're online or offline. Imagine two phones connecting directly with Bluetooth. The sender creates and signs the transaction. The receiver gets it, verifies the signature and the state update right there on their own device. Boom. Done. You have immediate mutual finality between the two of you. And get this, it has the exact same security guarantees as if you did it over the internet. That's a huge deal.
Okay, but let's be real, this design isn't a silver bullet. Nothing is. Moving away from the world computer model comes with real, tangible costs. It's super important to be honest about the trade-offs. So, to be fair, you have to look at what each system is good at. Blockchains. They are genuinely better for some things. If you need to coordinate a bunch of anonymous people who don't know each other, say for funding public goods, blockchain is great for that. Or for things like shared liquidity pools and DeFi, AMMs, that's where they shine. But DSM, it's built for that bilateral stuff, payments, messages, private contracts. So what's the big thing you lose with DSM? You lose that effortless or magical composability that you see in DeFi, where any protocol can just call any other protocol. With DSM, if you want two things to work together, you have to build an explicit connection. It's more work. But the flip side is huge. You gain predictability. You know exactly what you're interacting with, which means you remove that massive risk of some other random contract you've never heard of having a bug that drains your funds. And this brings us to the final and maybe the most important question of all. What should a global trust layer even be built for in the first place?
Well, the source presents this breakdown. It argues that if you look at the real world, something like 95% of all human economic activity is just bilateral. It's me paying you, it's us sending messages, it's two parties signing a contract. That's the stuff DSM is designed for. That other 5%, that's the complex anonymous coordination stuff. DeFi, public goods, where blockchains are a better fit. So the question becomes, where do you focus your efforts?
And this is really the core of the philosophical argument. The claim is that Ethereum made a choice. It built its foundation to optimize for that 5% edge case, and now it's trying to sort of patch and retrofit that incredibly complex foundation to handle the 95% of simple everyday use cases. The argument for DSM is that it does the exact opposite. Build for the 95% first.
And that really leaves us with the big question to chew on. When you're building the foundation for a new decentralized internet, do you optimize for the 95% of activity or for the 5%? There's no easy answer, but the path we choose will literally shape what our digital future looks like. So, what do you think is the right way to build?